Welcome back to our deep dive. Today is Thursday, February 26th, 2026. And I mean, looking at the wire this morning, the cognitive dissonance in the tech world is just getting a little loud, isn't it?
Yeah, it really is. It's honestly deafening at this point.
Because on one hand, you've got the hardware giants and the big model labs just screaming bigger. Like I saw the specs on Gemini 3.1 Pro this morning, and a 1 million token context window is just considered standard now.
Right, totally standard. And then you look at Zifra pushing that 380 million parameter monster.
Exactly. The message just seems to be, give it more brain, give it more text, and it'll figure it out.
That is the scale hypothesis in full effect right there. The idea that if you just shovel enough context into the kernel's intelligence, just sort of smokes out the chimney.
Which is a great way to put it. It's a very brute force approach to cognition.
Yeah, it is.
But then, and this is where the dissonance really hits, you talk to the people actually building applications, the engineers who are out there trying to get an agent to update a CRM or manage a support ticket queue or even just reliably format a date string. Oh, formatting dates is a nightmare.
Right. And those developers aren't talking about more context.
Yeah.
They're talking about, why did my bot just hallucinate a refund for a customer who doesn't even exist?
Exactly. We're seeing this massive bifurcation in the industry right now. You have the model builders who are basically chasing godlike reasoning capabilities and these massive sprawling context windows.
Yeah.
And then you have the system builders who are realizing that a godlike reasoning engine is actually a terrible employee if it just refuses to follow basic instructions.
It's like the difference between hiring a philosopher and an accountant.
Oh, I like that.
I mean, I might really enjoy having a debate with a philosopher about the nature of value or whatever, but I want the accountant to handle my taxes.
Yeah, you definitely want the accountant for that. And I want them to do it in the right boxes with the right currency every single time.
And you want the accountant to use the right tax forms and not write you a sonnet about the concept of debt. And that tension right there between the best effort creativity of an LLM and the guaranteed execution that enterprise software actually requires is exactly where we are diving today.
Yes, it is.
We're looking at a tutorial from MarkTech Post by Asif Razak that dropped last week on February 19th.
Yeah.
And the title is, well, it's a manifesto in itself, really.
I have it right here, actually. It's a bit of a mouthful. Let me read it. A coding implementation to build bulletproof agentic workflows with Pydantic AI, using strict schemas tool injection and model-agnostic execution.
Yeah, it's a lot to take in.
It is a massive salad of 2026 buzzwords. But I really want to parse that first part. Bulletproof agentic workflows, because agent is a very loaded word right now.
It really is.
Everyone claims they have agents. You look at any startup pitch deck right now and it says agentic, but most of them are really just chat bots with a shaved haircut.
That's a very fair assessment. A true agent actually does work. It changes the state of the world.
Right.
It writes to a database, it sends an email, it triggers a physical shipment in a warehouse.
Yeah.
And the moment you let an AI actually change the real world, a 90% accuracy rate isn't impressive anymore. It's a massive liability.
Yeah, if my logistics agent sends 90% of my packages to the right address, I am bankrupt in a month.
Precisely. So today isn't about the shiny new Gemini model or Zifra. It's about the cage we build around those models.
The guardrails.
Exactly. We're talking about Pydantic AI strict schemas and this concept of dependency injection. I know it sounds a little dry, but this is the stuff that actually separates the toys from the enterprise tools.
Absolutely. So before we get into the how of it all, let's drill into this best effort problem a little bit more, because I think a lot of people, even some developers, fall into the trap of thinking, well, if the model is smart enough, it just won't make mistakes.
Yeah, that's a huge trap.
Like they think if I use GPT-5 or whatever comes next, surely it knows how to write proper JSON by now.
That is arguably the single biggest fallacy in AI development right now. You really have to remember what an LLM actually is under the hood. At its core, it is a probabilistic engine.
Right.
It is predicting the next token based on a statistical likelihood derived from petabytes of training data.
It's basically playing Family Feud with the entire internet. It's guessing the most popular answer on the board.
Exactly. And usually the most popular answer is the correct one. But most likely is not the same thing as definitely.
Not at all.
When you ask a model to generate a JSON object for an API call, it's not actually thinking about the syntax rules of JSON.
It doesn't know what JSON is.
No, it doesn't. It's just predicting that a curly brace usually follows a colon in this specific context. It's mimicking the structure. It's not understanding it.
So when I ask it to output a ticket ID and I expect an integer, say the number 1cert24, the model might decide that order number 134 looks a little nicer.
Right? Or it might decide to bold it with markdown asterisks.
Well, I've seen that so many times.
Or it might even write it out as a Roman numeral, because maybe the user's query was written in a super formal tone, and the model is trying to match that. The model is genuinely trying to be helpful. It's trying to match the vibe of the conversation.
But in strict software engineering, matching the vibe is literally a bug.
It's a fatal bug.
It crashes the entire pipeline. The database throws a type error, the API rejects the payload, and the whole workflow just dies right there.
And this is exactly where the concept of the ephemeral agent comes, in which the source material touches on quite a bit.
Yeah.
This is another massive part of the reliability crisis we're seeing in 2026.
Ephemeral, so meaning temporary, right? Like short-lived.
Right. Most of these agentic workflows are stateless. The default state of an LLM is complete amnesia.
Okay.
Every single time you send a request to an API, you are essentially spinning up a completely fresh instance of the universe for that model.
It has no memory of what just happened.
Exactly. It doesn't know what it said to you 5 seconds ago unless you manually feed that entire chat history back into the prompt.
Which is exactly why we have these massive 1 million token context windows now, just to cram all that history back in every single time.
Correct. But doing that creates incredible fragility. If your agent depends on reading 50 pages of chat history just to understand that client A prefers email over phone calls, you are betting your business that the model pays attention to page 37 every single time you query it.
And we know from all those needle in a haystack tests that they absolutely do not do that. Sometimes they just skip right over the middle of the context.
They hallucinate. They get distracted by irrelevant details. So you have this ephemeral brain operating on probabilistic logic, trying to interface with a strictly deterministic system like a SQL database. It's just a recipe for absolute chaos.
So the old way of fixing this, and by old way I mean like 2024 or 2025, was prompt engineering.
Oh, yeah.
You'd write in all caps in the system prompt, do not use Roman numerals, only use integers if you fail. I will be very sad.
The shouting at the model phase of AI engineering. We have all been there. You write these massive block text system prompts, just begging the AI to behave. Please, I beg of you, return valid JSON this time.
It really feels like managing a stubborn toddler sometimes.
It really does.
Yeah.
And the problem is it's not scalable at all, because then a new model version comes out. Say you switch from GPT-4 to the new Hermes agent, and suddenly Hermes interprets the word integer slightly differently.
Right.
Or it decides it vastly prefers XML over JSON for some reason, and your entire carefully crafted prompt just falls apart.
So you're constantly tweaking your instructions just to keep the car on the road. You're completely locked in. You've over-optimized for one specific brain.
Exactly. And that is the exact fragility that Asif Razak is attacking in this article. He's saying we have to stop shouting at the model.
We have to stop relying on vibes.
Yeah. We need a strict contract. We need a mechanical mechanism that enforces the rules of the system before the data ever touches your backend infrastructure.
Enter Pydantic. Now, for the Python heads out there listening, Pydantic is already legendary. It is the absolute bread and butter of data validation in the Python ecosystem.
It is the gold standard.
But putting it together with AI and Pydantic AI, that is the big shift here.
It is a huge shift. Pydantic is famous for being incredibly strict. If you tell Pydantic in your code this specific field must be an integer, and you hand it a string, it doesn't just frown and try to make it work.
No, it throws a fit.
It raises a hard validation error. It stops the assembly line immediately. It is the bouncer at the club. If you don't have the right ID, you are not getting in.
And what Pydantic AI, the specific library we're discussing today, does is it takes that bouncer and puts him right between the LLM and your actual application code.
Precisely. It builds a wall.
Let's break down this contract concept a bit more. The article calls it strict schemas. Now, I know what a traditional database schema is, but how does this apply to an open-ended conversation with a robot?
So think of a schema as a rigid blueprint for communication. In a standard chatbot setup, the input is just unstructured text, like, hey, do this for me. And the output is unstructured text, like, okay, here's the result.
It's basically free-form text generation.
Right. It's unstructured. A schema completely changes that dynamic. It essentially says to the model, I do not just want text back. I want a highly specific structured data object.
Okay, give me an example of how that looks in practice.
Sure. So imagine you were building that ticket management system from the tutorial. You need the AI to create a support ticket. What does a support ticket actually look like in a database?
It needs a title, maybe a priority level, a category.
Right, maybe it needs a Boolean flag. A true or false for is escalated.
Right. And priority can't just be any random word the AI thinks of. It has to be specific to the database.
Exactly. In Pydantic, you define a Python class. You explicitly say the priority field is a string, but not just any string, it's an enum, an enumeration. It can only be one of three exact value, high, medium, or low.
So if the AI tries to be creative and says urgent or top priority or super important, those are suddenly illegal moves.
They're completely illegal. They violate the strict contract you set up.
Okay, so step one is clearly defining this blueprint, this Pydantic model. But here is the part I really want to understand mechanically, because this is where the magic happens. The AI generates the wrong thing right. Let's say it outputs urgent. Pydantic sees it acts as the bouncer and screams error.
Yes.
Now, usually in normal software, an unhandled error is just the end of the line. The program crashes, the user gets a 500 internal server error pop-up, and everyone is unhappy.
Right. In a fragile, old-school AI pipeline, that is exactly what happens. The pipeline shatters.
But the article specifically claims this workflow is bulletproof. It claims the agent self-corrects. How does it do that? Does the Python code actually talk back to the AI?
This is the magic loop. This is exactly where we move from simple data validation to true agentic behavior. Pydantic AI intercepts that validation error. It literally catches the exception in Python. And instead of crashing the program, it takes the exact text of that error message. Literally the text that says validation error values hearing. Urgent is not permitted, expected high, medium, or low.
Yeah.
And it feeds that exact error string back into the LLM as a brand new system message.
Wait, really? So it effectively just says to the AI, hey, you messed up and here's exactly why. Try it again.
Yes, exactly. It appends the error directly to the chat history. So the context window the model sees now looks something like this. User says, my internet is completely broken. AI says, okay, I'm creating a ticket with priority urgent. System steps in and says, error, urgent is not a valid priority. Valid options are high, medium, low.
And because the LLM is an LLM, it actually reads that error.
And it reasons about it. It looks at the error and goes, oh, my bad. Urgent clearly maps to high in this system. I will output high instead. It regenerates the response. This time it perfectly matches the schema. Pydantic validates it. The bouncer lets it through. It passes, and the final function executes.
And the human user who submitted the ticket, do they see all this back and forth negotiating happening?
Not at all. As a user, you experience zero latency. Well, maybe a few hundred extra milliseconds of compute time, but zero visual errors. You just see a little loading spinner, and then your ticket is created perfectly.
Yeah.
But under the hood, the agent literally self-healed. It reasoned its way out of a runtime bug.
That is just fascinating. The article calls this turning a runtime crash into a reasoning step.
That is hands down my favorite line in the entire piece. In traditional programming, we are so used to treating errors as absolute failures. But here, errors are just prompts. They are automated course corrections.
It really strikes me that this completely solves the prompt engineering problem we were just talking about.
It does.
You don't need to write a 10-page essay in the system prompt begging the AI to be perfect and predicting every possible mistake. You just need a super strict validator that catches it when it inevitably isn't perfect.
Exactly. You can actually be much looser with your initial prompt because you are vastly tighter with your validation rules. You don't have to predict every single way the model might hallucinate or fail. You just rigorously define what absolute success looks like via the Pydantic schema, and you let the retry loop handle all the messy negotiation.
So that covers the brain, or rather the discipline we're imposing on the brain. But an agent needs to do more than just think and output JSON. It needs to actually act. It needs hands. And the outline mentions tool injection as the next big piece.
Yes, this is the second major pillar of a bulletproof workflow.
Tool injection kind of sounds like something you get done at a dentist's office, but I assume we're talking about dependency injection from standard software engineering here.
We are indeed. For the non-developers listening, dependency injection, or DI, it's basically a fancy way of saying don't hard-code your tools inside your functions. Pass them in from the outside when you actually start the job.
Okay, why does that matter so much for an AI agent?
Well, think about the ticket system example again. To actually create a real ticket, the agent needs to talk to a database.
Right.
Right.
Has to save it somewhere.
In a sloppy script, you might just give the agent the global database password or direct connection string, and just let it run raw SQL queries whenever it wants.
That sounds completely terrifying, like an absolute nightmare. Drop table users.
Exactly.
Ugh.
Or select all from employee salaries. You absolutely do not want an LLM having unrestricted conversational access to your core infrastructure. It is a massive security vulnerability.
So how does tool injection fix that specific problem?
Instead of giving the agent the master keys to the castle, you give it highly specific, severely limited predefined functions. You actively inject these approved tools into the agent's operating context.
Like giving it a specific toolkit belt for the job.
Yes, and the tutorial shows this very clearly.
Yeah.
The Author Raise Act defines exactly 4 tools for this agent: create ticket, query ticket, update ticket, and list tickets.
And that's all it gets?
That is it. The agent literally cannot physically do anything else. If a user tries to trick it and asks, hey, delete this ticket, the agent looks at its tool belt and just says, I don't have a tool for that. I can't do it.
It severely limits the blast radius of a hallucination or an attack.
Drastically.
Yeah.
But the injection part is also hugely important for testing. Let's say you want to aggressively test your agent to see if it handles an angry customer correctly. You really don't want it actually writing fake data to your real production database during an automated test.
Right. You don't want to pollute your real metrics with thousands of fake angry test tickets.
So because you are using dependency injection, you can just swap out the real database tool for a mock tool during testing, a fake database that just lives in memory.
Oh, that makes sense.
The agent itself has no idea it's a fake database. It doesn't know the difference. It thinks it's doing real work. But you can run 10,000 automated tests safely without touching production data.
This is standard, robust software engineering practice, but applying it so strictly to AI code feels very fresh right now. Usually AI code you see on GitHub is just this tangled mess of raw API calls and print statements.
And that is exactly the core point Razak is trying to make to the community. We have to stop treating AI code like weekend hackathon scripts and start treating it like real rigorous enterprise code.
Like grown-up software.
Exactly. The article also dives into something called context dependencies, which ties into this.
What are context dependencies? How is that different from tool injection?
So imagine you have a multi-tenant SaaS system. You have data for client A and data for client B living in the same database. You need to make absolutely certain that the agent working on behalf of client A cannot, under any circumstances, see client B's private tickets.
Oh yeah, that's huge. That is a massive privacy lawsuit just waiting to happen if they cross over.
With Bidantic AI, you can securely inject the current user context directly into the tool itself behind the scenes. So when the LLM decides to call the list tickets tool, the tool itself checks, wait, who is asking for this list? And it automatically filters the database query at the code level.
So the agent doesn't even have to know that it needs to filter the results.
Exactly. The agent is completely oblivious. It just says, give me the tickets. The tool handles all the complex security routing.
That is really smart because it effectively offloads the critical security logic from the probabilistic, quote-unquote, dumb AI down to the deterministic smart Python code.
Yes. You should never, ever trust the LLM itself to enforce your security policies. Enforce them strictly in the tools you inject.
Okay, so we've got the strip schema, which is the contract. We've got the tools, which are the hands of the agent. Now let's talk about the workflow itself. The article builds this whole ticket management system. Walk us through the happy path and maybe a not-so-happy path.
The happy path is pretty straightforward. A user says, my monitor won't turn on. The agent classifies the text, calls the create ticket tool with a valid priority and category to the database updates, and the agent replies to the user saying, I've created your ticket.
Very boring. I love it.
But the not-so-happy path is where this architecture really shines. Let's look at the async execution part of the tutorial.
Yeah, why is async so critical here? The tutorial really makes a big deal about setting up an async-first environment.
Simply because LLMs are incredibly slow.
They really are. Sometimes waiting for that token generation to finish can feel like an absolute eternity.
In computer time, it is literally an eternity. It's an ocean of time. If you are running a synchronous standard Python script, your entire application thread just completely freezes while the AI is sitting there thinking.
Okay.
So if you have 100 customers trying to file support tickets at the exact same time, the 100th customer is sitting there waiting 10 minutes just for the web page to load.
Which is completely unacceptable in a modern app.
Exactly. With an asynchronous setup, the system fires off the API request to the LLM and then immediately goes off to do other useful things while it waits for the network to respond. It can juggle hundreds of these API calls in parallel, on a single server.
It's non-blocking.
Correct. And when you combine that asynchronous power with the self-correction loop we talked about earlier, it becomes incredibly powerful.
How so?
Imagine an agent makes a mistake generating a complex schema. It gets the validation error. It has to retry. That retry requires another full API call, which takes more time.
Right.
But because everything is async, the rest of your system simply doesn't care. That internal struggle where the agent is trying to find the right answer happens entirely in the background. It doesn't block other users.
So you get this intense reliability, but it doesn't come at the cost of total system paralysis.
Exactly. You hide the latency of the retries behind async execution.
There is one more major pillar here from the article that I think is probably the most strategic point for any business leaders or CTOs listening right now. Model agnostic execution.
Oh yes, this is the ultimate future-proofing pillar.
Because we started this whole deep dive talking about the insanity of Gemini 3.1 Pro and the Zifra 380 million parameter model, next week it's going to be GPT-5 or Claude 4 or Llama 4. The model landscape is changing almost weekly at this point.
And the pricing models are changing weekly too.
Right. So usually when a team builds an AI app, they lock in to a specific vendor. They aggressively optimize all their system prompts just for GPT-4. They rely on exactly how GPT-4 handles nuanced formatting instructions.
Yeah.
And if they suddenly try to swap in Llama 3 locally to save money, everything just breaks because Llama 3 needs an entirely different style of petting to get the same output.
That is classic vendor lock-in, and it is a terrifying place to be for an engineering team. You are completely beholden to one single company's API uptime and one single company's pricing strategy.
So how exactly does this Pydantic AI approach solve vendor lock-in?
It solves it by deliberately abstracting the core logic away from the fragile text prompt and moving it down into the rigid Python schema and tools.
Unpack that a bit. How does that abstraction work?
Remember the ticket priority schema we talked about earlier?
Yeah.
Priority must be high, medium, or low. That is a universal logical concept.
Right.
It honestly doesn't matter if the brain interpreting it is a massive trillion-parameter OpenAI model or a tiny open-source model running locally on your laptop. As long as the model is just smart enough to understand the basic concept of mapping urgency to high, medium, low, the system simply works.
Because the contract remains exactly the same, even if the signatory changes.
Exactly. All of your actual business logic, the database connections, the strict error handling loops, the complex tenant security checks that is all hard-coded in Python. It is solid rock. The only thing the LLM is actually doing is reading the input and filling in the blanks on the form.
So if OpenAI suddenly triples their API price tomorrow morning, I can basically just change one single line of code, the model name string, and switch my entire workflow over to Anthropic.
You might need to tweak a high-level system prompt very slightly, just for tone, but fundamentally, yes. The underlying architecture of your application does not change at all. You aren't rewriting your app. You are quite literally just swapping the engine.
The source material specifically calls this swappability.
And it is absolutely critical for long-term survival. It effectively turns the AI model itself into a baseline commodity, a completely replaceable component. You can swap a V6 engine for a V8 engine without redesigning the entire chassis of the car.
Provided you build the chassis correctly in the first place,
Yep.
which really seems to be the overarching theme of this entire deep dive.
That is the theme. Most people in the industry right now are essentially duct taping powerful rocket engines to wooden skateboards. This tutorial is fundamentally about taking the time to build a titanium chassis.
So we've covered the technical weeds here. Let's zoom out a bit. We are sitting here in 2026. Context engineering is the massive buzzword of the day. Every tech headline is shouting about who has the biggest, most massive context window. But this article is arguing for something fundamentally different.
It really is. It's essentially arguing for constraint engineering.
Constraint engineering. I really like that framing.
While everyone else is desperately trying to make the AI smarter by just giving it millions of tokens to read this approach, makes the AI vastly more reliable by intentionally giving it fewer choices.
Less is more.
Think about it this way. If I hand you a totally blank sheet of paper and say, hey, write me a status report, you might write literally anything. You might mess up the date format. You might forget key metrics.
I probably would, honestly.
But if I hand you a highly structured IRS tax form with tiny little boxes that forces you to enter specific data in a highly specific way, you really can't mess it up unless you just refuse to fill it out.
Even if you are an absolute genius, the rigidity of the form keeps you grounded to the task at hand.
Exactly. The source article talks about closing the reliability gap. We have spent the last 3 or 4 years trapped in this endless demo phase of AI. Incredibly cool demos on Twitter, really impressive open-ended chats. But systems you fundamentally couldn't trust with your actual bank account or your customer database.
Because at the end of the day, they were still just best effort text generators.
Right. But engineering approaches like this, strict schemas, secure tool injection, infinite self-correction loops, these are the things actually bridging that gap today. We are finally moving from cool, brittle demo to dependable, boring production system.
And the ultimate goal mentioned in the piece, which I think is so crucial, is recovering from these inevitable errors without manual human intervention.
That is the absolute holy grail of automation. The human developer doesn't have to step in and manually fix a missing comma in the JSON payload. The human support agent doesn't have to constantly reprompt the bot because it got confused. The system handles its own messes in the background.
It effectively recovers the actual human time we were promised AI would save us in the first place.
Yes, perfectly said. If I have to spend 5 minutes manually fixing a database entry because the AI hallucinated the output format, I might as well just done the data entry myself. It's useless.
Yeah.
But if the AI catches its own mistake and fixes itself in 200 milliseconds, I am actually saving real time.
I do want to quickly touch on that Hermes agent headline from the sidebar before we wrap up today. It mentioned fixing AI forgetfulness.
Yes, I saw that.
It seems like Pydantic AI fixes this concept of forgetfulness in a totally different way, doesn't it? Not by adding more memory, but by enforcing strict process.
That's a really sharp observation, actually.
Yeah.
The Hermes approach tries to fix forgetfulness by giving the agent a massive, persistent long-term memory store, which is valid for certain use cases. But Pydantic AI fixes it by making the immediate microscopic interaction so rigorous that historical memory matters a lot less.
It really doesn't matter if the agent completely forgot who I am or what we talked about yesterday, as long as the current specific request is violently validated against the current schema.
Precisely. It renders the whole ephemeral, amnesiac nature of the agent significantly less dangerous to your system.
So let's summarize all of this for the listener who is maybe driving to work right now and just wants the hard bullet points to take back to their team. What are the 3 core pillars of a truly bulletproof agent?
Okay, pillar 1 is strict schemas. Stop asking your models for plain text. Demand a rigidly structured object and use a validator like Pydantic to ruthlessly enforce it.
That's the contract.
Pillar 2 is tool injection. Do not ever give the agent global, unfettered access to your systems. Inject specific, safe, highly testable functions that severely limit the blast radius if the model goes rogue.
That's the tool belt.
And pillar 3 is model-agnostic design. Build your core business logic in Python code, not in English prompts. Make the underlying LLM a totally swappable component so you aren't ever locked into a single vendor's ecosystem.
And that's the chassis.
Exactly. And of course, wrapping all of that in that beautiful self-correction loop, letting the hard validation errors automatically drive the model's reasoning.
This entire conversation has really shifted my perspective today. I came into this still somewhat thinking about AI as this magical, constantly evolving digital brain, but now I'm really just thinking about it as another software component. A very messy, probabilistic one, sure, but one that can absolutely be managed and tamed.
That shift in perspective is the true sign of a technology finally maturing. I mean, when electricity was brand new, it was treated like magic. It was a spectacle. Now it's just a utility. It's completely boring.
Yeah.
We desperately need AI to become boring.
Boringly reliable.
Exactly. Boring is good in enterprise software.
I want to leave everyone listening with a final thought to chew on today. We spent this entire hour talking deeply about how to force an AI to follow strict, rigid contracts, how to make it bulletproof against mistakes. But honestly, it makes me wonder if you look at your own organization right now, look at your own human team.
This is a dangerous line of thought.
How many of our own human workflows are just best effort? How often do we as professionals send emails that completely miss the point? How often do we accidentally enter data into the wrong column in a spreadsheet?
Honestly, all the time. Humans are the ultimate messy, probabilistic engines.
Yeah.
We are incredibly creative, but we are notoriously error-prone when it comes to repetitive structure.
Exactly. So if we can genuinely build these AI agents that are deeply constrained by these strict mathematical schemas, agents that literally catch their own mistakes and self-correct before they ever hit the send button, are we rapidly reaching a point where the AI is actually far more rigorous and reliable than the human it just replaced?
I really think we are. We are starting to hold AI to a standard of absolute mechanical perfection via this code that we very rarely hold ourselves to.
The source material mentions that context engineering is the big new frontier for 2026. But maybe the real frontier isn't engineering the context at all. Maybe it's simply giving the AI a much better rulebook than we ever give ourselves.
I think you're absolutely right on that. The code is ultimately the perfect manager.
Definitely something to think about the next time you fire off a quick best effort email to your boss.
Indeed it is.
If you are building right now and you want to actually see the Python code for this, and I highly recommend you do, seeing these Pydantic models in action is deeply satisfying for a nerd like me. Definitely go check out Asif Razayev's full article on MarkTech post. It really is a masterclass in modern system design.
Definitely worth your time to read.
Thank you so much for joining us for another deep dive. We will be back next time to decode whatever wild new paradigm the tech world throws at us next.
See y'all then.